Good morning, students. This is Anjali, Assistant Professor, Department of CEC, AIML, IARE, Hyderabad. Today's our topic is Statistics for Data Science. In previous class, we have completed 2 modules and now we are starting with the third module, Statistics for Data Science. Now, before moving towards our main topic, we will recall the previous class topics. In previous class, we have learned that collectively exhaustive events, random variables, probability distribution for random variables, and spatial probability distributions. Collectively exhaustive event means whatever you have got some events, that events are behave like a collectively. That means we can say that, for example, we have one of the sample space and that sample space containing some values. That values are collectively, we can say that values are collectively exhaustive event. But for example, this is our N of S 1, 2, 3, 4, 5, 6. That means I'm saying that I roll a one dice, and definitely after rolling a die, we will get the some events like 1, 2, 3, 4, 5, 6. But what happened when we have to find out the probability for each event? So at that time, your probability will be 1 by 6. So that probability will not change. So we can say that these events are, these values are, this set is collectively exhaustive event. Then we can say that then random variables, for example, random variables means that variable which are using for denotation purposes. Just for example, we can say x. X is our random variable. That random variable will contain some discrete random variable and continuous random variable. That means this discrete random variable and continuous random variable have some limitations. They will contain sometimes the values which are in the continuous format and some values which are in the interval format. Then after that we have seen that probability distribution for random variable. So in probability distribution and spatial probability distributions, both distributions are very important. Both distributions are particular for the probability. There are different Poisson distribution, normal distribution. These are our probability distributions, and in probability distributions we are using some random variables, discrete and continuous discrete random variable. Both are very useful for our probability distribution. So every term like collectively exhaustive event, random variables, probability distribution for random variables, spatial probability distribution, every term is related to with each other and every term has its own functions. Now we will move towards our main topic, statistical foundation of data science. First, we will see that statistics. What is meant by statistics? Before we have seen so many things like data science, its levels, its steps, but now we will see that the statistics. The statistics is a mathematically based field which seeks to collect and interpret quantitative data. That means we can say that the statistics is related to quantitative data. So definitely if it is the data, if it is containing data, so at that time we will collect data, we will interpret the data, and And in contrast, actually data science is multidisciplinary field which uses scientific methods, processes, systems to extract the knowledge from data in the range of forms. So, in data science also, actually data science is a multidisciplinary field which uses some methods, processes, some systems for extracting the knowledge from the data in the range of the forms. That means we know that the basic definition of the data science is the collection of machine learning techniques, collection of mathematics, business intelligence, computer science engineering, all these are data science. And this data science is totally related to statistics. And it is the generally science concerned with developing and studying methods for collecting, analyzing, interpreting, presenting empirical data. That means this statistics is totally related related with the data science and for the developing, studying the methods for collecting, analyzing, interpreting, presenting empirical data. So whenever we will collect the data in the statistics, we can say, or in data science, every data is important for the analyzing, interpreting and some presenting your data. In advanced machine learning algorithms, in data science, utilize the statistics to identify and convert the data patterns into the usable evidence. That means in machine learning algorithm, actually machine learning algorithm is used in the data science. But for what purpose we are using the machine learning algorithm in data science? Because we have to utilize the statistics for identify and for converting our data patterns into the usable evidence. And that evidence are very useful for our data science, for our statistics. Data scientists use statistics to collect, evaluate, analyze and draw conclusions from data as well as to implement quantitative mathematical models for pertinent variables. Generally, nowadays, see, data scientists uses statistics. But these statistics generally used for the collecting, evaluating, analyzing, some draw the conclusions from data, as well as for implementing your your quantitative mathematical models for the variables. And these statistics is generally concerned with exploring, summarizing and making the inferences about state of complex system. Just we can say that one of the example is there, the state of nation, official statistics, state of people's health, medical and health statistics, and the state of the environment statistics. These are the best example of statistics. State of the nation. State of the nation, that means it is related to official statistics. The state of the people health, it is related to medical and health statistics. Then the state of the environment, it is related to environmental statistics. So these are in best examples of the statistics, and the statistics is the one of the best way to get the information from numerical data. And in the starting only, I said that the generally statistics is our mathematical based field from where we will collect the data, we will interpret the quantitative data. And this statistics is generally used for estimating and measuring our parameters. That means which parameters we are using in our statistics. So those parameters we have to estimate, we have to measure. And the important role of the statistics is to represent the unstructured data in the form of tables, graphs and charts. Generally in the statistics, we will use to represent that data in the form of tables, graphs and charts. And we can combine two columns of data, for example, date and passenger count, in single chart for showing the structural way. And in data science only we have learned that the when we will collect the data, that data should be either in the unstructured format or structural way. But if we will collect, if we want to arrange that data, so definitely we will arrange that data in the form of table format. So that data is the structural way. And mathematicians generally used to play with the numerical data for calculating the mean and variance. And these things, mean and variance, are very useful in the statistics of the data science. And finally, we can make some decisions based on the plots, charts, and tables. Now, we will see the comparison of data science and the statistics. First, the amount of data on which a data scientist works is generally large, and they will perform tasks with the large data. And the statistics still depend on conventional and small scale methods of the data collection, such as experiments and surveys. Data science will perform some operations, some tasks on the large data. But in statistics, what will happen? In statistics, generally statisticians are totally depends on your conventional and some small scale of methods. And that methods are generally experiments. Sometimes on the basis of survey, on the basis of experiment, we will collect the data. Then data science generally focuses on comparing many methods to make the simplest machine learning model. That means this data science generally completely focus on machine learning model. And the statistics is validating a particular model for verifying with testing the data and the help of the charts and some error matrices. Then data scientists tend to come from engineering backgrounds and are thus focused on generally on making the sure the result of the research are fed back into the operational system. And the statistics are usually trained by the math departments. So both data science and statistics both are different terms, but both are related with each other. Now there are two main ways of collecting the data for our analysis. One is observational and another one is experimentation. First, we will see the observation. That means these things are observational and experimentation. These things are involved in the obtaining data. That means how we will obtain the data, either observational or experimentation. That means there are two ways, by observing your data or by experimenting. So first we will see that the observational. We might obtain the data through observational means, which consist of measuring specific characteristics but not attempting to modify the subjects being studied. What is saying that what is meant by observational? That means it will consist of some measuring specific characteristics, but it will not allow to attempt or to modify the subject being the studies. Just for example, we can say that you have a tracking software on your website and that observes users' behavior on the website. Tracking software is your just example of the observational, how you will collect the data only by observing, by tracking software, and such a length of the time spent on certain pages and the rate of the clicking on ads on the while not affecting the user's experience. That would be an observational study. That means how much time you are spending on particular pages, how much time you are spending on the particular website, how many the rate of the clicking on the ads, different advertisement, and these things will not affect on the user's experience. That means what we are doing, we are observing those things. Just we are observing those things. And this is the one of the most common way to get the data, because it's a plain easy. Now all of you have to do is observe and collect the data. So in observational studies are also limited in the types of data you may collect. because the observer is not in control of the environment. That means the observational is not control of the environment. And who is observer? We are the observer. And you may only watch and collect the natural behavior. What you have to do? Just you have to watch, just you have to observe, and you have to collect the data by natural behavior. And if you are looking to induce a certain type of behavior, an observational study would not be useful. And in an observational data collection method, you acquire data by observing any relationship that may be represent in the phenomenon you are studying. That means in observational data collection method, you have to acquire data only by observing any relationship between the things. And there are 4 types of observational methods that are available to you for the researcher. Just one is cross-sectional, case control, cohort, and ecological. Now, first we will see the cross-sectional. In a cross-sectional study, you only collect the data on observed relationships 1. That means in cross-sectional study, just you have to observe, and you have to watch, and after that you can collect the data. And this method has the advantage that is it's cheaper and taking less time as compared to case control and cohort. And these cross-sectional studies can miss relationship that may arise over time. That means in cross-sectional, we have to observe, we have to watch, and we have to collect the data. But best advantage is that it is a very cheaper method. It will take the less time, but there is disadvantage also. Sometimes it can miss some relationships because of only overtime. Then case control. Using a case control method, you create the cases and controls, then observe them. Here what you have to do, just first you have to create the cases and then you have to control on them. And after that you have to observe it. A case has been exposed to phenomenon of interest while control has not. And after identifying the cases and controls, you move back in time to observe how your event of the interest occurs in the 2 groups. But this is why case control studies are referred to as a retrospective. Just we will take one of the examples. Suppose medical researcher suspects a certain type of cosmetic is causing a skin cancer. You recruit people, you took people who have used a cosmetic. That means it is the case. That are the cases. And those who have not used the cosmetic, that are the controls. You took people who have used a cosmetic, that are the cases, and who doesn't use the cosmetic, that are your controls. You request participants to remember the type of the cosmetic and the frequency of its use. How much you have used. Just which type of cosmetic you have used. We have to request to participants, and on that basis we can observe what is happening there. And this method is also very cheaper and it will take the less time as compared to cohort method. But however, this approach has some limitations also. When individuals you are observing cannot accurately recall the information. So these things mostly we have to perform in the group, in the team. We refer to this as a recall bias because you rely on the ability of participants to remember the information. And in the cosmetic example, recall bias would occur if participants cannot accurately remember the type of cosmetic and the number of time used. So here, in case control, we have taken the example of the medical researcher which have some people has skin cancer, and by using the cosmetic at what time, how much we have used, all these things we will observe. Then cohort. In a cohort method, you follow people with similar characteristics over a period. That means this cohort technique will contain some similar characteristics. And this method is advantageous when you are collecting data on occurrences and that happen over a long period. Generally, it has a disadvantage also. Mostly it is costly and requiring more time. And it is not suitable for occurrences that happen rarely. Then ecological. There are the three methods we have discussed previously collect data on individual. When you are interested in studying the population instead of individual, you use the ecological method. That means here, there is no need to study on the individual. You have to study in group. For example, say you are interested in lung cancer rates in Iowa and North Dakota. So you obtain a number of cancer cases per 1,000 people for each state from the National Cancer Institute and then compare them. And then you can hypothesize possible causes of differences between the two states. What we have done? We have to find out the lung cancer rates in the Iowa and the North Dakota. Now we have to obtain the number of cancer cases per 1,000 people for each state from the National Cancer Institute. And now we will compare them. And after comparing, we have to hypothesize these possible causes, differences between the two states. And when you use this ecological method, you will save your time, you will save your money because data is already available. Data is already available on the site. So there is no need to go and no need to communicate with individual person. Directly you will get the answer, directly you will get the result on the site. So that we can say that data is already available on the site. That is the ecological method. However, the data collected may lead you to infer population relationship that do not exist. Now, this is all about the obtaining data. Now we will see observational. Now we will see the experimental. An experiment is data collection method where you as a researcher changes some variables and observe their effect on other variable. Experiment means what we will do? We will collect the data. Then we will do some experiment. Then we will change some variables and we will observe the what is affecting, what effects are going on that particular variable. And these variables we can manipulate and we will refer to as independent, while the variable that change as a result manipulation are dependent variables. Imagine a manufacturer is testing the effect of drug strength on number of bacteria in the body. Company decides to test drug strength at 10 mg, 20 mg and 40 mg. For example, drug strength is an independent variable. We can say that drug strength is an independent variable. And the number of bacteria is your dependent variable. Number of bacteria is your dependent variable. So the drug administered is treatment while 10 mg, 20 mg and 40 mg are the levels of treatment. And the greatest advantage of using an experiment is that you can explore the causal relationships that an observable study cannot. Additionally, generally experimental research can be adapted to different fields like medical research, agriculture, sociology and psychology. And this experiment have one of the disadvantage also, being expensive and requiring a lot of time. Definitely, if we will do some experiment and we don't know the when we will get the result, when we will conclude our experiment. So definitely that thing will take expensive also. That thing is very expensive also, and it will take so much time also. Now we will see the sampling data. Data sampling is statistical analysis technique used to select, manipulate, and analyze representative subset of data points to identify patterns and trends in the large data set is being examined. And generally, their data sampling is a statistical analysis techniques which is used for this selecting, manipulating, analyzing some subset of the data points for identifying the patterns. And when you conduct the research about the group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. That means whenever most of the time it happens that it's very difficult to collect data from every person. And a sample is a group of individuals who will actually participate in the research. Just we will take the example of the class. In the class, there are mostly 60 students, and that 60 students are population. But only 5 students are performing a task. That means it is a sample. 5 students is a sample. So 60 students are population and 5 students are sample. That means to draw valid conclusion from your result, you have to carefully decide how you will select a sample, and that is representative of the group as a whole. And there are two types of the sampling methods. One of the probability sampling and another one is non-probability sampling. Probability sampling involves the random selection, allowing you to make the strong statistical inferences about the whole group. In probability sampling, it will allow to make some strong statistical inferences. And in non-probability sampling involve non-random selection based on the convenience, other criteria allowing to easily collect the data. Now, first we will see population versus sample. First, you need to understand difference of population and the sample and identify the target of research. The population is the entire group that you want to draw the conclusion about. I already told that 60 students means 60 students in the class means it is your population. But 5 students out of 60 performing some task, that means that 5 students are sample. And we can say that the sample is a specific group of individuals that you will collect the data from. And the population can be defined in terms of the geographical location, age, income, many other characteristics. That means population can define in the terms of different things. Geographical location, income, age, and so many things are there which are related to the population. And it can be very broad or quite narrow also. And maybe you want to make inferences about the whole adult population of your country. Maybe your research focuses on customs of a certain company and patients with specific health condition or students in a single school. And it is important to define your target population according to the purpose and practicalities of your project. That means population and sample, both things are very different. Just we have taken the example customers of the certain company, some patients with specific health condition, students in the single school. These all are example of the sample and the population. And it is important to define the target population according to the purpose and practicalities of your project. If population is very large, demographically mixed and geographically dispersed, that means it might be difficult to gain access to a representative sample. Now you can say that this is the example based figure of the population versus sample. With this is your population and this is the group from where we have selected, and this is your sample. This is your specific group. This is your specific group, and this is your people group. And from this we have decided this thing, and this is specific group is your sample. Now sampling frame. The sampling frame is the actual list of individuals that the sample will be drawn from, and ideally it should include the entire target population and nobody who is not part of that population. That means sampling frame means it is the actual list of individuals where a sample will be drawn. And just we can take the example, you are doing research on working condition at company X. Your population is all 1000 employees of the company, and your sampling frame is company's HR database. That means which lists the names and contact details of every employee. Sampling frame is your company's HR data, your company's HR database, and that database is containing some list, and that list is containing names, some contact details of the employee. And then we will see the sample size. The number of individuals you should include in your sample depends on various factors, and that will include the size, variability of population, and your research and design also. There are different sample size calculators and formulas which are totally depends on what you want to achieve with the statistical analysis. This is your sample size. Then probability sampling method. Probability sampling means that every member of the population has a chance of being selected. For example, that means in probability sampling, that means every member of the population, every number has a chance to be get selected, and it is mainly used in the quantitative research. And if you want to produce the result that are representative of the whole population, probability sampling techniques are most valid choice. That means if you want to produce the result which are representative to a population, so at that time you can use the probability sampling. There are four main types of the probability sample. First one, simple random sample, systematic sample, stratified sample, and cluster sample. Now we will see one by one. Simple random sampling. In a simple random sampling, every member of the population has an equal chance to be get selected, and your sampling frame should include the whole population. Your sampling frame will maybe include whole population. To conduct this type of sampling, you can use tools like random number generators, then other techniques which are totally based on entirely on the chance. For example, we can take, you want to select a simple random sample of 100 employees of company X, and you assign a number to every employee in company database from 1 to 1000. And now you use a random generator to select 100 numbers. This is the example of the simple random sampling. See, in this simple random sampling means just you are selecting a group of people 1, 2, 3, 4. I selected from this. That means that four person group is my sample. It's my sample, and this is population. Now, systematic sampling. A systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. And every member of population is listed with number, but instead randomly generating numbers, individuals are chosen at a regular intervals. For example, all employees of the company are listed in alphabetical order, and from first 10 numbers, you randomly select the starting point, number 6. You selected the number 6, and then from number 6 onwards, every 10% on the list is selected, and you end up with the sample of the 100 people. That means 6, 16, 26, 36, and so on. That means you are selecting the person after some interval, after some particular interval, and where it can finish 6, 16, 36, 26, 46, 56 till 96. Here you can see systematic sampling. Here this people got selected, and see there is a particular event also, particular interval also. Then if you use this technique, it's very important to make sure that there is no hidden pattern in the list, and that might skew the sample. For example, if HR database groups employees by team and team members are listed in order of the seniority, and there is a risk that your interval might skip over people in junior roles and resulting in sample that is skewed towards the senior employees. Now we will see the stratified sampling. Stratified sampling involves the dividing the population into the subpopulation that may differ in important ways, and generally it will allow you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. And for using this sample method, you have to divide your population into the subgroups. Then that means we can say that it is your strata, and which is based on the relevant characteristics. For example, gender, age, range, income, and job. So, based on overall proportion of the population, you can calculate how many people should be sampled from each subgroup. Then you use random or systematic sampling to select a sample from each subgroup. For example, the company has 800 female employees and 200 male employees. Now you want to ensure that the sample reflects the gender balance of the company. So you sort the population into two strata based on the gender. That means first one is 800 female employees and 200 male employees. Then you use the random sampling on each group and selecting 80 women and 20 women, which gives the representative sample of the 100 people. Now you can see here stratified sampling. We have selected. Now then we will see cluster sampling. Cluster sampling involves dividing the population into the subgroups. In stratified also, population divided into the subgroups, but there is a different things. But here what is happening, in each group, each subgroup should have a similar characteristics. There should not be different characteristics. They should have a similar characteristics. Instead of sampling individuals from each subgroup, you randomly select the entire subgroup. And if it is practically possible, you might include every individual from each sample cluster. If clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This is called multi-stage sampling. And this method is good for dealing with large data dispersed population, but there is more risk of error in the sample, as there could be substantial differences between the clusters. See, there is a cluster sampling. See, that means from population we have to divide into the subgroups, and then we have to select the particular specific groups. It's very difficult to guarantee that the sample cluster are really representative of the whole population. For example, company has offices in 10 cities across the country, and all with roughly the same number of employees in similar roles. And you don't have the capacity to travel to every office to collect your data. So what you will do? So you use a random sampling to select 3 offices. These are your clusters. Now, unequal probability sampling. In simple random sampling, probability that each unit will be sampled is the same. Each unit will be sampled is the same. Sometimes estimates can be improved by varying the probabilities with units are sampled. For example, if we want to estimate number of job openings in a city by sampling firms in that city. Many of the firms in the city are very small, and if one of the user size of the firm is not taken into the consideration, and typical sample will consist mostly small firms. However, number of job opening is heavily influenced by the large firms, and thus we should be able to improve the estimation of the number of job openings by giving the large firms a greater chance to appear in the sample. For example, with probability proportional to size or proportional to some other relevant aspect. Now we will see the selection probabilities. On each draw, the probability that a given population unit will be selected is denoted as P of I and I is equal to 1, 2, 3 to the and so on. Suppose that sampling is with replacement, probability of selecting the ith unit in the population is P of I. And if the selection probability are unequal, the sample mean is not unbiased or population mean, and sample total is not unbiased for population total. That means what we have said, if the selection probabilities are unequal, sample mean is not unbiased for the population mean, and sample total is not unbiased for the population total. For example, if larger firms are sampled with a higher priority, the sample mean for job openings will be biased upward. This is all about the unequal probability sampling. In this class, we have seen that statistics of data science. These are your references. These references you can refer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.